Hello everyone, welcome in the lecture of discrete mathematics and probability theory. In the previous lecture, we have studied the definition of set, representation of set, and types of sets. So today lecture we are going to discuss the power set, Venn diagram, and set operations and their property. So first I will discuss here power set. So what is the definition of power set? So here we assume S is a set, then the power set of S is the set of all subset of the set S, and it is denoted by P of S. For example, if you look at here, we have taken S equals to 0, 1, 2. This is a set. When we find the subset of this, so we will get 2 to the power 3 means 8 subset. And when you apply the set, means set of all subsets, so you will get the power set. So this is a power set of the set S. Look at here, 5, 0, 1, 2, 0, 1, 0, 2, 1, 2 and 0, 1, 2, 3. This is a similar here. The modulus of two vertical lines, so the cardinality means number of elements. So cardinality of the set S is a 3, so cardinality of power set is 8. And another example, 5, we have to find the power set of 5. So 5, there is no element, but when we find the subset, so there is mentioned 2 to the power n means 2 to the power 0 equals to 1, so there is a 1 subset. So we know that every set is a subset of itself, so 5 is a subset of itself, and set of all subset is known as a power set. So this is a power set of 5. If a set has n elements, then the power set will have 2 to the power n elements. So cardinality of A, suppose that n, then the cardinality of power set of A 2 to the power n. Another is a Venn diagram. A Venn diagram is a pictorial representation of sets in which the universal set is represented by interior of the rectangle and other set are represented by the interior of circle that lies inside the rectangle. So here we have taken the rectangle means box represent the universal set and the circle represents the sets, other sets. So we have taken the example of the set vowels in alphabet. So vowels of English alphabet is A, E, I, O, U. So there is a universal set will become all the letter of English alphabet. So this is a universal set and this is a set of English vowels letter. Next is operations on sets. So first union of two sets. So here we assume that A and B are two sets. Then the union of two sets A and B denoted by A union B like this, and is the set of elements which are in A or in B or both. Means in the union of two sets, the elements belongs to the set A or set B or both. So in the mathematically we have written A union B equals to X such that X belongs to A or B, and this is a graphical representation of A union B. Means you can say that this is a Venn diagram of the set A union B. So below area represents the union of A and B. Here we have taken the example A equals to 1, 2, 3, 4, 5 and B equals to 5, 7, 4, 3, 9. Then we find the A union B. So means if the element belongs to A or B or both, so it comes under the union. So here is a 1, 2, 3, 4, 5, 6, 7, 9. Another is a operation intersection of two sets. The intersection of two sets A and B denoted by A intersection B is the set of elements that belongs to both A and B. That is, in mathematically we can write A intersection B equals to x such that x belongs to A and x belongs to B, means the common element. So for example, you take here A equals to 1 2 3 4 5 6 and B equals to 5 7 4 3 9. Then we find the intersections, means common elements. So there is a 3 elements which are belongs to both the set A and B. So it comes under intersection. A intersection B equals to 3 4 5. And here below area represents the intersection of two sets A and B, means common element. Disjoint set. If A and B do not have any elements in common, then the set A and B are said to be disjoint. Mathematically, A intersection B equals to 5. So here we have taken the example A equals to 1 2 3 4 and B equals to 5 7 9. Then we find the intersection. So there is no element are common in these sets, so A intersection B equals to 5. So A and B are disjoint set, and this is a graphical representation of disjoint set, means you can say that this is a Venn diagram of disjoint set. So here we have taken the few example for practice, so you can do the practice. So look at here is a first set contains 1 2 3 and second set contains 3 4 5, and you have to find the union. So in according to definition of union, if the element belongs to A or B or both, so it comes under the union. So you will get the union of 1 2 3 4 and 5. In next example, the first set contains the New York and Washington, and another set contains 3 and 4. So when you find the union, so you will get all the elements in the union, means New York, Washington and 3 and 4. Similarly, you can calculate the union of 1 and 2 and 5, so you will get 1 and 2. When you another set, here is a 1 2 3, another set is 3 4 5, then you have to calculate the intersection. So there is a one element is common in both the sets, so you will get the 3, means intersection is a 3. And you have to check if these two sets are disjoint or not. So there is a one element are common, so these sets are not disjoint set. And suppose that if you want to find the intersection of 1 2 and 5, so you will get 5, means there is no element are common. Next operation is a complement. If U is the universal set and A is any set, then the set of elements which belongs to U but which do not belongs to A is called the complement of A, and it is denoted by A dash, A complement and A bar. In mathematical it is written as X belongs to U and X not belongs to A, and this is a Venn diagram of complement. Here blue area shows the complement of the set A. Relative complement of or difference of two sets. If A and B are any two set, then the set of elements that belongs to A but do not belongs to B is called the difference of A and B, or relative complement of B with respect to A, and it is denoted by A minus B, or A divides B. That in mathematically A difference B, you can set X such that X belongs to A and X does not belongs to B. Look at here the example, A equals to A B C D and B equals to A C F G. So when you find the A difference B, means A minus B, so you have to check the element of the set A. So the element A belongs to A and A also belongs to B, so it is not comes in the A difference B. B belongs to A but B not belongs to B, so that's why we have written here B. C belongs to A, C also belongs to C, so it not comes. And D belongs to A but D not belongs to B, so A difference it comes under the A minus B difference. Okay, so A minus B is become BD, and this is a Venn diagram of the set A minus B. And similarly you can find B minus A. Any element which belongs to B but not belongs to A. So there is a two elements which belongs to B but not belongs to the set A. And this is a graphical representation of the B difference A. Another definition, symmetric difference. The symmetric difference of the set A and B denoted by A symmetry difference B, or it is also an A direct sum B, consisting of those elements which belongs to A or B but not to both. This is a mathematical definition. A symmetry difference B equals to X such that X belongs to A or X belongs to B and X does not belongs to A intersection B. Means A union, in another form you can also write A union B minus A intersection B. So if you see the Venn diagram of the difference of two sets, here we have taken the A and B are two sets. So the pink region shows the area of asymmetry difference B. For example, look at here, if A equals to this, B equals to this. So first off you have to find the union, then intersection, and then you have to find the A difference, union B difference, A intersection B. So you will get 1, 3, 5, 6, 7. Here we have taken the example for the practice. So look at here, here is a one set contains 1, 2, 3, another set contains 3, 4, 5. So when you find the difference, A difference B means the elements which belongs to A but not belongs to B. So there is a two element which belongs to A but not belongs to the set B. So 1 and 2. So similarly you can also find the difference between this set and this set. So you will get the element of the first set because there is no element are common. Okay, similarly you can also find the difference of this set. There is no element common, so you will get the exact first set. Okay, and suppose that if you want to find the complement of this set, so when you find the complement of this set, so you have to also think about the universal set. So sometimes universal set are given in the question, or sometimes maybe you have to think and you have to consider that what is a universal set of this set. So suppose that here we consider ki set of integer number is a universal set. So when we find the complement, so the complement of this set contains all the element of the universal set except the element present in the set A. Suppose that here A equals to this. So this is a complement of the set A, means minus infinite. Suppose that is starting from, so here is dash minus 2, minus 1, 0, but not include 1, 2, 3, and also include the 4, 5, 6 up to infinite. Similarly, you can also calculate the symmetric difference. So 1, 2, 3 is given here. Then you have to find the symmetric difference 3, 4, 5. So first you have to find the union intersection. Then you have to find the A union B minus A intersection B. So you will get this. Similarly, also you can check the next example. Okay, so you will get the symmetric difference. And here 1 and 2, and here is a 5. So you will get 1, 2. Okay. Proper subset of Venn diagram. So what is the meaning of the S subset R and S not equals to R? So when it is a subset but not equal to, it means it's a proper subset. So this is a proper subset of R. So we have to make the Venn diagram. So first we make the rectangle for the universal set U. Then S is a subset of R. So we make first circle S and then make the outside of the circle R. So S is the inside of the circle R. So S is a proper subset of R but not equals to. Okay. The example here is X is given this, Y is this, then we have to find the union, so we will get this, then we find the intersection, so we will get this, when we find the difference X difference Y, so we will get this set, when we find the difference Y on X means Y minus X, we will get this, when we find the symmetric difference, we will get this. So this is the example. Okay, then here is some properties. So properties for the union: identity law, domination law, idempotent law, commutative law, this is the associative law, and these are the property for the intersection: same identity law, domination law, idempotent law, commutative law, associative law, and this is a property for the complement sets. So complement, whole complement is a set, complement union a set, so you will get the universal set, and A intersection complement set is, we will get the 5. So the guys, today lecture we have studied the first power set, then Venn diagram, and the properties of the set and operations. So thank you for watching the lecture and bye bye.